Good day everyone, I'm Laika Elaine Ramos from BSCS 4A. Today I will be discussing Lamport'S mutual exclusion algorithm. Lamport'S mutual exclusion algorithm. What is Lamport'S algorithm? Is a permission-based algorithm proposed by Lamport as an illustration of his synchronization scheme for distributed systems. In permission-based, timestamp is used to order critical section requests and resolve any conflict between requests. What is mutual exclusion? When a process is accessing a shared variable, the process is said to be in a CS or critical section. No two processes can be in the same CS at the same time. This is called mutual exclusion. Lamport'S algorithm. To enter critical section, when a site S1 wants to enter the critical section, it sends a request message to all the other sites and places the request on request queue. Here, TS1 denotes the timestamp of the site S1. When a site S receives the request means request from site S1, it returns a timestamp replay message to site S1 and place the request of site S1 on the stamp. To execute the critical section, a site S1 can enter the critical section if it has received the message with timestamp larger than TS1 from all the sites and its own request is the top of request queue. To release the critical section, when a site S1 exceeds the critical section, it removes its own request from the top of its request queue and sends a timestamp release message to all the other sites. Explain algorithm. In this algorithm, there are three types of message: request, reply, and release are used, and communication channels are assumed to follow FIFO order. A site sends a request message to all other sites to get their permission to critical section. A site sends a reply message to requesting site to give its permission to enter the critical section. A site sends a release message to all other sites upon exiting the critical section. Every site S1 keeps a queue to critical section request ordered by their timestamp. Request queue denotes the queue of the site S1. A timestamp is given to each critical section request using Lamport'S logical clock. Timestamp is used to determine priority of critical section requests. Smaller timestamp gets high priority over larger timestamp. The execution of critical section requests is always in order of their timestamp. Message complexity. Lamport algorithm requires incubation of 3N1 message per critical section execution. This 3N-1 message involves request message, reply message, and release message. Drawbacks of Lamport'S algorithm. Unreliable approach. Failure of any one of the processes will halt the progress of entire system. High message complexity. Algorithm requires 3 messages per critical section invocation. Performance. Synchronization delay is equal to maximum messages transmission time. It requires 3 messages per critical section execution. Algorithm can be optimized to 2 messages by omitting the reply message in some situations. Example of Lamport'S mutual exclusion algorithm. There are 3 sites in this figure, S1, S2, and S3. In a critical state, S1 and S2 boost requests, but S2 is the first to read the timestamp, which means S2 should be the first to enter the critical state. S1 and S2 are, we can see them all as attitudes with other sided from S1 to S2. So from the message to the end, which is this one on the critical statement, means it has 4 on 2 resources. S2 receivers 1 and 2 due to the fact that there are 2 locations in which the message must be transmitted. The algorithm steps have been request from execution and critical statement again. Step 1. Request the critical state and execute, then list from the critical state so that the other process can use it. Step 2. Must be complete in the same manner as the first time, with the time state being forced to enter into a critical state. And step 3, when S2 goes into a critical state, release all the previewed resources, and S1 is demonstrated to be the critical state. And that's it.